Actually, we might have to wait for people to come, I guess. I mean, I don't know. I'm chill with just interacting with Maxwell. All right. I don't know. I have a question for you, Maxwell. Would you rather have infinite cake or infinite ice cream for the rest of your life? You can only choose one, and no ice cream cake, because I know that's the type of answer that you might answer.
Ice cream.
Ice cream, interesting. I would pick ice cream too. What's your favorite flavor? Just wondering.
Salted caramel.
Salted caramel. Yo, that's my favorite too. Wow. My second favorite would be pistachio, I'd say. But salted caramel, nothing beats caramel, I have to say. Maybe if you like toss in some cookie dough and waffle cones, you can make salted caramel even better. All right. Spaghetti bridge is almost done. I can go over something with Maxwell, and then we can just do something for fun, I guess. I already made a Kahoot for the class, I guess. Let's see. I need to get to my slides. All right, class 8, our final class and final topic, number theory. Okay, Maxwell, this is going to be sort of like a tutoring session because it's just me and you one-on-one. All right, curious, how much do you know about number theory already? I know you're pretty bright compared to, I don't know, the average AMC 8.
Probably a lot.
What? All right, let's see. Prime numbers. You already know prime numbers, right? Oh, what? That's weird. I think my slide accidentally cut it off. Okay. Oh, yeah. I wrote too much. Okay, prime number. I'm assuming you already know what a prime number is, right?
Yeah.
All right, prime factorization?
Yeah, I know.
Yeah, all right. Counting the number of divisors? I think
Number
this is kind of weird. So this is like asking for the number of, if you want to find the number of divisors of like a really big number, you have to use prime factorization, right? It's like combinatorics and this.
I know how to do that.
All right, cool. Odd divisors, only find odd.
I know how to do that too.
You know how to, what? I'm trusting you, by the way. Square?
Yeah, I think I know how to do that.
All right, let's start from here then. Prime factorization, you're gonna have one prime to some a1, another prime to a2, blah, blah, blah. So for a divisor to be a square, the power of the prime has to be square as well. So the power of all the primes has to be an even.
I know how to do that.
All right, the floor of a1 plus 2, okay, cool. Wow, 2 slides left. Expansion to broader concept. Using similar logic, consider if I want to find the number of divisors that are cubes. Or cubes or to the nth power. How about, what do you think of this?
Over 3 instead of over 2.
Yeah, and over n. And then GCD and LCM. Kind of a weak place to end, right? I'm assuming you already know this.
Yeah.
All right. That's literally all the number. That's all the number theory you'll see, and like extra. Like I piled in stuff that you'll see in AMC 10 for this lesson, and you already know it. So I don't think I can do anything to help you in number theory. Any other math?
Is there like a sum of factors?
Sum of factors? What do you mean by sum of factors? Like the sum of the factors of a number?
No, like the the sum of factors of a number.
Like, you find a number, you find all of its divisors, and then add up all of the divisors.
Yeah.
Yeah, is there a formula for that?
Yeah, there is.
There is? I think you're right. Let's make a blank slide. All right, do you have the annotation option? Can you like annotate on my screen?
Okay, sure.
All right, we're gonna solve this together. All right, given a number n. All right, sorry, given a number with prime factorization p1 to the a1 plus, not plus, I'm being dumb, times p2 to the a2 dot dot dot. Can we find a formula for the sum of the factors?
Well, yeah.
Yeah. All right, why don't you start us off? So explain your thought process to me. I think I have to show, can you annotate? I think you have to go to the top.
The text thing.
The text? Oh, you're going to do text? Okay. You can click on annotate, I think, and then a big, like a bar of functions shows up.
Oh yeah, I forgot to change the color. Yeah. It equals this.
I can't see anything yet. I think you have to like, I don't know, finish before. All right, so are you typing right now? I'm curious. Okay, so I can't see it right now, so I think you have to like, once you're done, you click enter and then I'll be able to see it. All right, 1 plus p1 plus p1 squared plus p1 to the a1, yeah. I mean, yeah, that's pretty much it. 1 plus p1 squared. Do you think there's a way to get a factorial somewhere? Like simplify this into something with a factorial instead of a product? Maxwell?
No, I don't think so.
So, oh shoot, I broke my spaghetti. Let me try and think about this. 1 plus p1. I know this is right, but I think there's a way to get like a factorial somewhere. I mean, as long as you know this, I think you should be fine. This probably won't even show up until like AIME. What school do you go to, and what grade are you in again?
I go to RJ Gray, and I'm in 8th grade right now.
You're in 8th grade. Oh, okay. Archie Gray. Oh, what state are you in?
Massachusetts.
Massachusetts. Huh. Massachusetts. Whoa. You're in 8th grade right now. I'm a junior. So next year we might see each other on the competition plane. That's really frightening to think about. Wow. That's really frightening to think about. But when I don't remember this formula and you do, and you're like 3 years younger than me. Oh shoot, I gotta step up my game. All right.
Think about it this way: if you expand this thing, you get
Yeah,
all the
I
factors.
understand it now just by reading it. But like, I couldn't think of a formula. I didn't want to start proving it.
That help?
Do you have anything else you want to go over? I got a problem for you. Really interesting.
Okay.
If you want to think about it. If you want to hang on here. All right, I've been building a spaghetti bridge for one of my classes. And one thing that's interesting, if you hold a spaghetti together and apply force to the ends and snap it, you're always going to get 3 pieces of spaghetti. It's not going to snap in one location, it's going to snap in 2. Why do you think that is? It is that way. I know this isn't really related to math, but it's still an interesting problem to solve.
How?
How? You want to guess? Oh shoot, where did my spaghetti go? See, that's the problem with science. It gets messy. I'll find where they are later.
Because it's a curve, I guess, and not like you bend it in it's bent in one spot.
Yeah. So since you're applying forces to 2 spots, you're gonna get like sort of a parabola. You can think of.
Yeah.
There's a vertex of a parabola, but that's not where the force is because I'm still applying my force like horizontally, and the thing is, but the spaghetti is now curved. That means that we're gonna have like 2 different places with 2 different forces, horizontal and vertical. So that's basically why. I don't know. I just think it's really cool. Okay, did we go over sequences and series in this class? I don't think I went over sequences and series, right?
You haven't yet.
I haven't yet. How much do you know about it?